So let's start. So first of all, thank you all for all the sponsors that you have on this session. I will also have to say that, like you mentioned, I'm actually doing this live session. I'm doing it from Israel. Right now it's 1:20 a.m. I'm awake since 5 a.m. since I have little kids at home. So I'm really sorry if I look really tired, but but it is in fact what happening right now. But it was really important for me to do this session live. So it'll be also available for Q&A in the end. So first of all, I'd like to welcome you all by with your native language. So I will try to do it without butchering it. So please forgive me. So tena koto katoa ko Eyar Zilberman taku in Goa. Tena koto katoa. And I will also greet you in Hebrew, which is my own native language. שלום לכולם, תודה שהצטרפתם אליי לשמוע את ההרצאה שלי, which basically means, hello everyone, thank you for joining me to hear this session. So, who I am. So, my name is Eyar Zilberman, like I mentioned, and I'm a developer and also a YAML engineer. I also have another hat, which is I'm a co-founder and leading the product at datree. I also founded the biggest GitHub user group in the world, which is more than 3,000 members, and we are doing sessions for the community around open source and GitHub. I also love regex, but I really hate SQL. And yes, I'm fully aware that I have bunny ears on my head, and let's put it on the table, it's a gimmick. But if you stay until the end of the session, I promise to explain exactly why I'm doing it. Okay, so just for you to understand, so datree, basically the company that I'm leading the product, is an open source project. It's right now it's have almost 6,000 stars, and it's a popular project, and it's help developers and engineers to prevent Kubernetes misconfiguration from reaching production. The way that it's doing it, it's actually a CLI and a cluster webhook that is connected to your environment or your local environment, and you can define different policies, and every time that you submit or apply changes to your configuration, it will make sure that it's actually valid against your policy. And this is how I actually was introduced into the topic that we're going to talk about today, which is the schema itself, because this issue came from our own users. And this is why I needed to actually investigate this topic and became advocate for schema validation for Kubernetes for some reason. Okay, so let's cover the basic about what is exactly Kubernetes schema validation. So it's basically a set of unit tests to verify a manifest is containing the right properties. Let me show you an example. So here's an example of invalid Kubernetes file. And just from looking at it, it's really hard to understand why it's invalid. But let me show you how it's look when it's actually a valid one. So it's really easy to miss the fact that deployment should be written with uppercase D, and namespace should be written also with a lowercase s. And this is actually the kind of stuff that are validated by the schema. As you can see, those are properties inside the manifest itself. And like I said, those are kind of unit tests. Like we have unit tests for code, this is a unit test for your configuration. This is basically what the schema is doing. And you're probably asking yourself, so who is responsible to define the schema and the properties that are tested? So the answer is you, me, the community. So because Kubernetes is open source, the schema is also open source, and people can contribute more unit tests or checks to the schema itself, and this way make it more complete. So now that we understand what is schema, let's talk about what is not included in the schema. So any YAML validation is not included in the schema. So you can have a file that is valid for Kubernetes, but it's not a valid YAML file, again, because it's not part of the schema to make the YAML validation. So if you don't have correct indentation, it's not tested. Also, different kind of best practices that are related to configuration files in Kubernetes. So for example, there's a best practice that you want to make sure that all containers have a memory and CPU limit set. Because it's not mandatory and you can actually apply containers without those properties, it's not part of the schema. So this is another example of something that will not be included. Another example is, let's say that I know this is a conference around security, so let's take something from more from the security world, and make sure that all images are pulled from a private registry. Again, it's not something that is mandatory, therefore it won't be included in the schema. Those are kind of best practices or policies that are relevant to specific organizations. Therefore, it's not part of the schema, which is published to all Kubernetes users. And the last thing, there are also some validations that you expect to be part of the schema, but they are actually not part of the schema. And you're probably asking yourself, which kind of validations? So no spoilers, we're going to talk about it exactly. Okay, cool. So now that we understand what is schema, what is no schema, we understand that we need it. So how do I use it? So I have really good news for you. It's actually natively available every time that you are doing kubectl apply. Every time that you're doing this command, before the cluster accepting your configuration and applying it into your production environment or staging whatsoever, it will actually check the schema to make sure it's valid. And if it's not valid, it will reject it. It won't accept it. So that's cool. But there's also bad news. A lot of the time is actually too late. You're getting the validation only when you want to apply it, which is not a really good practice. So the question is, how can I check it earlier? What we call shift left. The answer is, there's actually a command which is called dry run, and it has two modes. One is client and one is server. And it will actually simulate applying resources to your cluster without applying them. This way you can actually get the kind of information that you will get if you actually will try to apply your cluster, and you can do it in a shift left mode. Okay, so now that we understand that we can do it with the flag dry run, let's compare the two status that we have. One is called server mode and one is client mode when we are using this flag. And what's the difference between them? So they are both performing schema validation, which makes sense. The server mode is performing extra validations. Again, don't worry, we speak about what is those extra validations. The client mode is not doing it. They are both not supporting different Kubernetes versions. Why do I mean by that? It will always validate, it will always validate the schema against the version of your cluster. So let's say that your cluster version is 1.18 and you want to upgrade to version 120. You can't validate against version 120 unless you actually upgrade your cluster, but then it's too late because you want to validate your configuration before you're doing the upgrade. And also the server mode is requiring a connection to a cluster, which makes sense. It's a server mode, and the client mode is also requiring a connection to your server, which not making sense at all. And you're probably asking yourself, why is that? So the answer is it's a bug. And you're probably asking yourself, okay, if it's a bug, why no one is fixing it? It's because they have a lot of other bugs that need to be fixed. Right now, Kubernetes project have more than 1,000 bugs that are open, and this is one of them. So the bad news is that it's actually making the client mode irrelevant, basically, if you want to use it. But I do have some good news. There's like recently development in this issue, and on April they published that on version 125 they are actually going to fix this bug. Stay tuned. I hope it will actually be fixed. So now that we know that we can't use the client mode, we can only use the server mode with a connection to a cluster. What can we do if we don't want to have a connection to a cluster, but we still want to validate in a shift left way our resources? So open source to the rescue, and in this gap we have two great tools. One is called kubeval and one is called kubeconfirm. They are both working in the same way. the way that they are working. So there's a Swagger file, which is containing all the definitions of the schema of the Kubernetes objects. And it's taking this Swagger file, converting it into a JSON schema, putting it in a different repository, and labeling each version. And then when you're making the validation with the tool, if it's kubeval or kubeconfirm, it will grab the right version for your cluster. You need to actually telling it, I want to validate it against a specific version, 118, 120, and it will pull the right schema definition from their inventory, and it will compare it with the manifest that you're trying to validate. Okay, so the question is, which one should I prefer? Should I use the kubectl dry run in server mode, or should I use the open source? So let's QA what's the difference between the two. So here's an example of Invalid manifest. And the reason that it's invalid is because if you can see the property app, the value is invalid. And if I would try to apply it, the server will reject it. So we know that kubectl will catch it, but apparently the open source project, which are kubeval and kubeperform, will not catch it. So that's one example. Another example, here's another manifest. Again, there's something invalid in this manifest, and what is missing is actually the property image. If I try to apply it without the property image, kubectl will reject it, but kubeval will not catch it. So you're probably asking yourself, why there's a discrepancy, why kubectl is able to catch it and the open source are not able to catch it. So you remember that we talked about what is not included. So no, we also said no spoilers. So this is the reason. Those are the kind of tests that you expect to be part of the schema, but they are not part of the schema. For some reason, they are happening in a Go script that is running only on the server side. And therefore, they are only catched if someone is actually trying to apply the resources, and they can't be catched if someone is using the schema definition of the Kubernetes itself. Okay, so who is the winner in this case? Which one should I use? So the answer is really, really simple. If you allow a connection to your cluster, you should always use the dry run in a server mode. But if you don't have a connection to your cluster, or you don't allow it, so you should use one of the open source tools. So in which situation you don't have a connection to your cluster? Basically, it's a best practice not to have a connection to your cluster, because you don't want to every developer or every person that in your organization, it can also, it doesn't have to be a person, it can be a machine, like a CI machine, have access to your production environment. Therefore, it's actually not a best practice that everyone will be able to use kubectl with the kubectl dry run in server mode. Okay, so now that we understand when we need to prefer one over the other, which one do we need to prefer, kubeval or kubeconfirm? So let's talk about Kubernetes version support. So kubeval is only supporting up until version 118. It wasn't updated. The schema that is comparing against wasn't updated in the last 2 years. While kubeconfirm is actually up to date. Version 1.24.2 is the latest version for Kubernetes, so it's super cool. Let's look at the community. So here's a screenshot of 2 projects on GitHub. As you can see, kubeval is a more popular project on GitHub. It's have almost 3,000 stars, while kubeconfirm have only just almost 600 stars. But if you look at the activity on the project, you can see that the last commit to kubeval was on 2021, while in kubeconfirm it was 14 days ago. So I took the snapshot 2 days ago. So this one is really, really important. So CRD support. And because we don't have a lot of time for this session, I will just run over it. So CRDs for those that are not familiar with that, is the way that a lot of the CNCF projects are actually connected to your cluster. It's a custom resource definition. you have the CRD and you have the CR itself that is created from the CRD. And you can actually apply the CRD and then create your own kind of resource, which is not a Kubernetes native resource. So in this example, I created a kind, and this kind name is bunny, which is not a native Kubernetes file, a native Kubernetes object, sorry. But as you can see, I can actually apply it. And if I will do kubectl get bunny, I will get the resource that I created. And inside the CRD, I can also define how the CR will look like. In this example, I mentioned that it's have to have a minimum of 1 replica. So Cld support, it's really, really important. A lot of production environments have it. Kubeval in their documentation mentioning that they are not supporting it, while kubeconform is actually supporting it out of the box. Funny story, they do support it, kubeval, but it's just not mentioned in their documentation. Again, this project is really unmaintained in the last 2 years. And I found that it is supporting CRD in one of the issues. And funny story, because it's not supporting CRD, this is exactly the reason why Jan, which is the author of kubeconform, created this project kubeconform, because he was missing this part of supporting the CRD. Okay, so who is the winner? It's a clear case that kubeconform is the winner. So let's talk about strategy for validating your Kubernetes schema. First, you want to shift left. You want to do it as soon as possible. And you should always prefer to restrict access to your cluster from the reason that we talked about. Having access to your cluster is actually dangerous. You want to make sure that only the right processes and machines have access to your cluster, and you want to gap it. The second thing is that you want to fill the gap. So we mentioned that if you're using kubeconform or kubeval or one of those tools to validate the schema, there are still some kind of validations that it will not catch, but are catched by the server if you're using kubectl. So there are different tools to do that. Datree is one of them. And in Datree, we have it out of the box, these capabilities. So if you use Datree, you will get Kubernetes schema validation. We are under the hood, we are using kubeconform, but we're also filling the gap that you will get if you're doing the server mode with kubectl. So you get the benefit of having both validations without a connection to a cluster. But there are also other tools that you can do that with, like Conftest and Kyverno. The only difference is that you will actually need to create those kind of validation by yourself. You need to create those rules, and you won't get them out of the box. So we talked about version upgrade. So with Kubernetes, the lifecycle is really, really short. Every 14 months, they're actually deprecating a version. Every 3 months, they are releasing a new version. So with this tool, it's really, really important that because you can actually validate your configurations files before you're doing the upgrade to make sure that you're not using a deprecated API. And like we talked, you can actually, you can also validate your CRDs. So it's really important to make sure that the tool is supporting it in a correct way. I will skip the CRD catalog project because we don't have time, so I'm sorry about that, but basically it's a really cool project that we created at Datree that help with this problem of the CRDs, because it can help you pull all the CRDs, convert them into JSON schema that you can actually use one of those tools to validate and shift left this validation on your CRDs. So that was really, really fast session, but if one of you have questions, I will stay here to talk about, but also if you remember later a question that you forgot to ask me, you can also contact me in GitHub, email, LinkedIn. There's also a blog post that I wrote about it. And you also need to know that the reason that I have those bunny ears is because this is how I want you to remember this session. You're probably going to ask yourself, I remember this guy talked about Kubernetes schema validation. I don't remember what is his name. We have a weird name, it's in Hebrew, and how can I find this session? So the answer is I have a repository. It's called Pink Bunny Ears. It's the only repository on GitHub with this name. Inside this repository, you will find this presentation and you find all the information that I talked about with all the relevant links that I showed you. So that's all from my side. Thank you very much. And like I said, I'm also here for questions.
Thank you very much, Eyar. It was a great talk. Are there any questions in the room? and I don't see any questions in the live stream. So thank you again, Eyar. We have your project name with the bunny ears. I'm sure everyone's going to remember that. So it'll be easy to track down if anyone wants to get hold of you after the talk. Can I have a round of applause for Eyar, please? Thank you again, and speak to you later.
Have a good day. Bye-bye.